Hi everyone, I'm Steph, the General Math Lecturer, and today we're going to be going through some questions from the focus studies. So the first focus study we're going to focus on is communication. So one thing you really need to know, and probably the most annoying part of communication, is data conversions. So converting bits to kilobits, megabits to gigabits, gigabits to terabits. If you want to, you can pause the video now and just write out this diagram here. It's really helpful for remembering how to convert data. And this is another one. So another thing to remember is one byte is 8 bits, and this helps you to remember how to convert the data. So also just pause it now and write this out. It's really helpful. But this is also on your formula sheet, so not to worry. Okay, so another thing we need to know when we're converting data and we are we're dealing with digital download and file storage. When they're asking for download speed and how long it takes to download data, remember it all goes back to your speed equals distance over time formula. And this is measured in bits per second, so BPS, or kilobits per second, kbps. And this is also on your formula sheet. Okay, so our first question. Michael was transferring some video files from his computer onto a USB stick. At some point during the transfer, he observed the information shown below. Part 1. Show that, at that time, approximately 3,072 megabytes of data remained to be transferred. Okay, so we need to find out how many megabytes is left to download. And we need to show that it's approximately 3,072 megabytes of data. So first we're going to find out how much data is here. So to find that out, we just go 6.44 minus 3.44. So here's 6.44 and there's 3.44. So just you have to find out how much data is there. So approximately that would be 3 gigabytes, but it wants the answer is in megabytes. So if we convert this to megabytes, we have to times that by 1,024, and we get 3,072 megabytes. Calculate the speed required to transfer 3,072 megabytes in 7 minutes. Give your answer in megabits per second, correct to the nearest whole number. Note that 1 megabit is 1 million bits. So we're working out the speed, right? So we know that speed equals data over time. Okay, so our data is going to be, we have to convert it from megabytes into megabits. So 3,072 megabytes into bytes, then into bits. So it would be 3,072 times by 1,024 times by 1,024 times by 8. This would be, so megabytes, so I just did megabytes to kilobytes to bytes to bits. And then after this, we'll have our answer in bits, but we need it in megabits. So in order to convert bits into megabits, we divide by 1,000,000, because that's what it says in our question. So it would be 3,072 times by 1,024 times by 1,024 times by 8 over 1,000,000. And that is how much data we have. Now, sorry, this is going to get a bit squishy, but let's work out time, the time it would take up here. So basically, the time is 7 minutes But we need to convert this into seconds because it's megabits per second. So 7 minutes into seconds is just 7 times 60. So therefore, our speed is our data divided by our time. If we're looking at our original equation. So all you do is put these two values together, substitute them into the formula, and you should get 61.356, and it says to the nearest whole number, so 61 megabits per second. And that's it. Okay, so now we're going to focus on driving. So in the HSC exam, in my HSC exam, I had a question about explaining the types of car insurances and stuff like that, and I did not expect it. And it did come up again last year in the 2016 HSC exam. So it's really important that you understand your key terms in the focus studies, because they can ask you to define terms that you've learnt about that you haven't really thought about specifically. So make sure you just go over your terms and remember what they mean. Okay, so the types of insurances we have are compulsory third-party personal insurance, third-party property insurance, and comprehensive insurance. I invite you guys to pause the video now and just review what these terms mean before moving on to questions. Okay, so another thing we can look at in driving is that flat rate car loans. So these are calculated using the fixed simple interest rates. So we all know our simple interest formula, I equals PRN. And for reducing balance loans, these are loans where simple interest is calculated based on the balance owing, not on the original amount borrowed. Okay, so let's look at this question here. So this table gives monthly repayments for every $1,000 borrowed on a reducing balance loan. Okay, so we know we're looking at reducing balance loans. Okay, so Jenny borrowed $21,500 to buy a car. Use the table to calculate the monthly repayment on this loan at 9% per annum over 3 years. Okay, so basically, we need to work out how many sets of $1,000 is in $21,500, because the monthly repayments are calculated for every $1,000 that you're borrowing. So let's work that out. So 21,500 divided by 1,000 is 21.5. So that's going to be our new principal. Okay, so now we need to work out what factor we're going to use in the table. So it's monthly repayments on this loan at 9% over 3 years. 3 years has 36 months. So now we just line up 36 and 9% for 9% per annum, and our factor is 31.8. So to find the monthly repayment, we go 31, so MR is 31.80 times by 21.5, and we get $683.70. So that's our monthly repayment. What is the total amount Jenny would have repaid on this loan after 3 years? Okay, so her monthly repayment, if we look at back at the last question, was $683.70. And the length of her loan was 36 months, so 3 years. So all we do now is just times that by 36 to see how much she would have repaid over the 3 years. And this is now $24,613.20. Jack's monthly repayment on a loan at 8% per annum over 5 years is $334.62. Use the table to calculate how much Jack borrowed. Okay, so we have to work backwards basically. So 5 years is 60 months. So that's going to be our period. 60 months. Okay, in this case, we're trying to work out the principal. So how much he borrowed is equal to the factor. So our factor will be 20.28 because these, when you intersect 60 and 8, you get 20.28. So 20.28 times by x, which is our principal, how much he originally borrowed, equals our monthly repayment, which is 334.62. Okay, so we just divide 20.28 on both sides. And this will give us what x equals, which is 16.5. And because it's for every $1,000 borrowed, we need to times our principal by 1,000. So that will give us 16,500. Okay, next question. Zuzo is comparing the cost of two different ways of travelling to university. Zuzo's motorcycle uses 1 litre of fuel for every 17 kilometres travelled. The cost of fuel is $1.67 per litre, and the distance from her home to the university car park is 34 kilometres. The cost of travelling by bus is $36.40 for 10 single trips. So which way of travelling is cheaper and by how much? Support your answer with calculations. Okay. So let's work out the cost for a motorcycle trip. So cost for one motorcycle trip. So the distance from her home to the university car park is 34 kilometres. So that's how long, that's the distance that she travels on the motorcycle. So we know that 1 litre gets us 17 kilometres. And 17 times 2 is 34. So therefore 34 kilometres gets us, we use 2 litres to travel 34 kilometres. And we know that it costs $1.67 per litre. So now all we have to do is go 2 times $1.67, so 2 litres times $1.67, and this gives us $3.34. Okay, so that's for a motorcycle trip. Now, cost for one bus trip. Okay, so it costs $36.40 for 10 single trips. So basically we just have to work out how much it costs for one trip. So we go $36.40 divided by 10, and this should give us $3.64. So therefore, we compare the two, it's cheaper to travel on the motorcycle, but by how much? So we go $3.64 minus $3.34, which is 30 cents. So therefore, motorcycle is cheaper by 30 cents. And yeah, you can write it as like using the dollar sign or the cent sign, it doesn't matter. Okay, so now let's move on to health. So in this topic, you'll need to know how to draw and interpret scatter plots. So we know that when it goes up, when the line's going up, it's a positive linear pattern, and when it's going down, it's a negative linear pattern. And when the scatter plot is non-linear, the line will not be a straight line, it'll be kind of rounded like that. And no relationship means the points are kind of all over the place. There's no direct relationship between the points. Okay, so another thing we need to look at is working out correlation coefficient. So this represents the strength of the relationship between two variables, or R. So a positive linear pattern is where our correlation coefficient is positive, and a strong one is when it's +1. A negative linear pattern is when our correlation coefficient is a negative number, and in this case a strong correlation, a negative correlation coefficient is -1, and no relationship is when R equals 0. So scatter plots start to look a little different when the relationship isn't that strong. So as you can see here, when our correlation coefficient is 0.3, it's kind of a bit like spread out. 0.5 getting closer to 1, it's more straight, and the points on the scatter plot are closer together. But if we have -0.8, which is very close to -1, look how close all those all the variables are together. They're all together in a straight line, or nearly a straight line, because a straight line would be -1, and they're much closer together. Okay, so in working out a correlation coefficient, we can use this scale to describe or approximate the strength of the relationship between two variables. So here we have +1 being perfect, so it would be like completely straight and all the lines, all the points on the scatter plot would be close together. And then at 1, -1 here, all the points on the scatter plot would be close together but going negatively. Okay, so another question that we can be asked about is the least square line of best fit, and we're usually asked to find what this line is, right? So the line of best fit is in the form of y equals mx plus b. So if we look at it here, change to blue. So the gradient being our correlation coefficient times by the standard deviation of y over the standard deviation of x, and then our y-intercept, or b, being the mean of y minus the gradient times the mean of x. So obviously, as you can already see, working out the least squared line of best fit takes a long time. And we need to know how to find all these things here with our calculators in order to substitute these values into our formula to get our line of best fit. Okay. So our first question, so the Australian Bureau of Statistics conducted a study to determine if a relationship exists between age and the number of times a person has visited a medical practitioner in the last month. The results are displayed in the table below. Okay, so the question states, what is the equation of the least squares line of best fit? Okay, so basically I've put the steps here of how you find out this, how you find the least squares line of best fit using your calculator. I highly suggest you keep practicing this in your study and you learn off by heart how to find this using your calculator, because in the exam it just saves a lot of time. So I highly recommend you guys pausing the video right now and just reading the solution for this question and practice doing it yourself on your own calculator. That way you've got some practice behind you and you can apply it to different questions. So now we have our equation y equals 0.095x minus 0.275. So we've got our equation of our line. Okay, so how do we draw this line? How do we draw this line of best fit? So what you do is you take two values from the previous example. So let's take x equals 25 and x equals 85. So using y equals 0.095x minus 0.275, what you do is you substitute your two chosen values and see that I've chosen two x values that are pretty far from each other. They're not close from each other. So it helps me draw the line. So you substitute your x values into this formula to get two corresponding y values. So when x equals 25, y equals 2.1, and when x equals 85, y equals 7.8. So you plot these points on your scatter plot with all the values in the table and you draw a line between these 2 points, and this is your line of best fit. So as you can see, we have the 2 points drawn on our graph, and we've drawn a line between them, and that is our line of best fit. Okay, so in medication, we are sometimes required to find how much milliliters of a particular concentrate we're meant to give to a child or an adult, and there are some formulas that we need to know to work out this. So we've got the volume required, so in milliliters, to say if it was like a liquid formula, would be the strength required in milligrams over the stock strength in milligrams times the volume of the stock in milliliters. So let's just look at some questions. So Matthew purchased a packet of 20 tablets for the treatment of his stomach cramps. Okay, 20 tablets. Each tablet contains 10 milligrams of hyoscine butyl bromide as the active ingredient. So the dosage instructions are as follows. So for adults and children over 6 years, and then take 2 tablets 4 times a day. Tablets should be swallowed whole with fluid. If symptoms persist after 48 hours, stop taking medication and consult physician. Okay, how many doses are in the packet? So 1 dose is 2 tablets, right? We can see that from the information here. Take 2 tablets 4 times a day. 1 dose is 2 tablets. A packet has 20 tablets. We saw that in our question. 20 tablets. So the number of doses in the packet is simply, so there's 20 tablets in a packet and 1 dose is 2 tablets. So all we do is 20 divided by 2, and that gives us 10 doses. Large amounts of the active ingredient, hyoscine butyl bromide, can cause side effects. What is the largest recommended amount of this active ingredient in milligrams that a person should take before consulting their doctor? So let's reread this part of our instructions. So it says, if symptoms persist after 48 hours, stop taking medication and consult a physician. So let's look at how much tablets they're taking a day. So 2 tablets is 1 dose, but it's taken 4 times a day. So we can see that here. So 4 times that is 8 tablets a day, which is 24 hours. Okay. So therefore, if we take 8 tablets in 1 day, so therefore it's 16 tablets over 48 hours, and that's 2 days. So it says that if the symptoms persist after 48 hours, you should stop taking the medications. That's the largest recommended amount of this active ingredient. So let's go back to the question. So it says that each tablet contains 10 milligrams, right? So 1 tablet equals 10 milligrams, right? But we have 16 tablets in 48 hours. So if we times that by 16, so 16 tablets equals 160 milligrams. So that is the largest recommended dose. Okay, and that's our answer there. Just underline that to make it clear. Okay, Matthew returned from the chemist at 9 a.m. on Saturday. Okay, let's just highlight a few things because this question is pretty long. Okay, so returned from the chemist at 9 a.m. on Saturday. So he got home at 9 a.m. on Saturday, right? And then he immediately took his first dose. He followed the directions stated, and after 3 doses, the stomach cramps had stopped. Matthew does not take any further medication. What was the date and time of his last dose? So if we go back to the question, it says that the person takes 2 tablets 4 times a day. So that means that in 24 hours, so we have to find out how many hours between each dose, right? So to do that, we go 24 divided by 4, so 24 hours in a day, and they're taking the tablets 4 times a day. So 24 divided by 4 is 6. So that means they take the tablets every 6 hours, right? Okay, so that means, so he took his first dose 9 a.m. Saturday, because it said that he took the dose like as soon as he got home. He must have been pretty quick. Okay, then if we know he takes it every 6 hours, so therefore his second dose would be 9 a.m. plus 6 hours, which is 3 p.m. on Saturday, right? Then third dose, so I'm just going to put here plus 6 hours, and then we're going to plus another 6 hours to 3 p.m. So 3 p.m. plus 6 hours is 9 p.m. on Saturday. So therefore, he only took up to 3 doses. So therefore, the date and time of his last dose was Saturday, 9 p.m. Okay, so our next topic for focus studies is resources. So for the questions in this topic, we need to revisit our area and volume formulas. So we need to know the volume formulas for various 3D shapes. So here we've got a cylinder. So the volume for a cylinder is pi times radius squared times the height. So basically you're finding the base, the area of the base, and then just timesing it by the height. So capacity rules that are really important to know. 1 centimetre cubed is equal to 1 milliliter, and 1 metre cubed is equal to 1,000 litres, which is 1 kiloliter. This is extremely important to know. So mark it down, highlight it in your book somewhere, because, so when you're asked to find the capacity, this is what you need to look at. A cylindrical water tank of height 2 metres is placed in the ground at a school. The radius of the tank is 3.78 metres. The hole is 2 metres deep. When the tank is placed in the hole, there is a gap of 1 metre all the way around the side of the tank. When digging the hole for the water tank, what volume of soil was removed? Give your answer to the nearest cubic metre. Okay, so basically here we need to work out how much soil they removed. So we know that this is the cylinder, we know the dimensions of the cylinder, right? But we need to take into account this extra 1 metre on the sides. So basically we need to find the volume of the cylinder plus these little 2 parts to find how much volume of soil they removed. So the first thing we need to find out is what radius are we going to use in our formula. So we have to take into account this extra 1 metre. So the radius is going to be 3.78, so that's the radius of the cylinder, of this water tank, plus 1. So it's taking into account this whole length here, not just the cylindrical radius. So this equals 4.78. And we know that the height is 2, so it's the same. So therefore, sub this into our formula, volume equals pi times 4.78 squared times by 2. This gives us 143.5607 ... and 144 rounded up. It's 144 meters cubed, and that's to the nearest cubic meter. Okay, so therefore the volume of soil that was removed was 144 meters cubed. Sprinklers are used to water the school oval at a rate of 7,500 litres per hour. Just write that bit nicer. The water tank holds 90,000 litres when full. For how many hours can the sprinklers be used before a full tank is emptied? So this one's pretty easy. All we have to do is work out how many hours it takes for 7,500 litres to make up 90,000 litres. So we just go, so number of hours equals 90,000, that's the full capacity, over 7,500. So it takes 12 hours to reach 90,000 litres. Water is to be collected in the tank from the roof of the school hall, which has an area of 400 metres squared. During a storm, 20 millilitres of rain falls on the roof and is collected in the tank. How many litres of water were collected? And as soon as we see this, we know it's a capacity question. So we need to be looking at our capacity rules. So let's say this is the top of our water tank, right? So this here is 400 metres squared. And this depth here is 20 millilitres, and that represents how much rain has fallen on the top of the water tank. So if we convert 20 millimetres into metres, so it's all in the same units, so that's 20 divided by 10 divided by 100. Oops. So that is 0.02 metres. Okay, so therefore to work out how many litres of water was collected, so the volume is A times H. So the area was 400 and the height was 0.02. So we put that into our calculators and we get 8 metres cubed. Okay, so from our rules, we know that 1 metre cubed is equal to 1,000 litres, which is equal to 1 kilolitre. They're looking for litres, so let's stick with this litres section. So if 1 metres cubed is 1,000 litres, then 8 metres cubed is 8,000 litres. Okay, so therefore 8,000 litres of water is collected. Okay, so we also need to know how to calculate water usage from provided graphs and data, and to calculate the perimeter of a dam, land or water catchment using a scale. So these are just coming from our syllabus. So to calculate the area of a dam, land or water catchment, we usually use Simpson's rule. So if we remember, this is Simpson's rule here for finding the area, right? So A is obviously area of the shape, H is the height of the equal parts. So they could give you the whole distance here, right? But you've got to find, if they give you the whole distance there, H is only this and this. It's not the whole thing. So you need to divide this by 2 or by 3 or whatever you need to do to get what H equals. So remember, it's height of the equal parts. DF is the distance of the first line. Then DM is the distance of the middle line, and then DL is the distance of the last line. And we just sub those values into our formula. We also use Simpson's rule for volume, working out the volume of a dam, land or water catchment. So this formula works quite similar to the previous formula, but we're obviously just working out volume. Okay, so the equally spaced cross-sectional areas of a water reservoir are shown. Using Simpson's rule twice, what is the approximate volume of the reservoir? Okay, so let's write our volume formula first. And we know that we're going to do it twice, right? So our first application, so let's write out our formula. Volume equals H over 3 AF plus 4 a.m. And as I've said previously, don't bother, if it helps you in the exam, please write out your formulas, but write out your formulas definitely when you're practicing for your exam. It's really important because it just gets you in the gist of using the formulas, writing them out, remembering them. Okay, so let's look first at what we're going to use for our first application. So I can split this reservoir into two, right? So I know, so if I work out let's work out what H is going to be. So I know this whole thing, right, is 8 kilometers. So therefore, it's divided into 1, 2, 3, 4 parts. So H is going to equal 8 divided by 4, which is 2 kilometers. Yeah? Okay. So it's going to be 2 divided by 3, the area of the first end. So 6.2 plus 4 times the area of the middle, so 8.1, plus the area of the last end, so 7.3. Okay, and we put this into our calculator and we get 30.6 kilometers cubed, always in cube because we're in volume. So second application, obviously we've already done this. Now we're going to look at the other side now. So volume, obviously, is going to be 2 over 3. The H doesn't change. And the area of the first end is 7.3. The area of the middle is 4 times 7.1. And the area of the last end is 6.0. Pop this into our calculators and we get 27.8 kilometers cubed. So the total volume is going to be 30.6 plus 27.8. And that is 58.4 kilometers cubed. Okay, so when we're looking at resources, we also have the topic of energy and sustainability. So a really good thing to remember is that 1 watt is equal to 1 joule per second. So that's energy for energy consumption. So this is our table here. I invite you to pause the video now if you'd like to write down these numbers. You will be asked in questions to convert between kilowatts to gigawatts, etc., etc. So yeah, always have this table to refer to. Okay, so a kilowatt hour measures the amount of energy used when a 1,000 watt or 1 kilowatt power source is used for 1 hour. So in a household of 4, each member uses an average of 13 minutes of hot water per day. There's 4 of them in this household. The household uses a 9 kilowatt hot water unit. Electricity is charged at 11.97 cents per kilowatt hour when the hot water unit is being used. What is the electricity cost for the hot water used by this household in 1 week? So let's see. 1 day, in 1 day, these people shower for 13 minutes each, and there's 4 of them. So that means in 1 day, the hot water is going for 52 minutes. And we want it for the week, right? In 1 week. There's 7 days in a week. So all we do now is to work out how many minutes the water is going for in a week is just 52 times by 7, which is 364 minutes. And then get that into hours, just divide it by 60. And we get 6 hours and 4 minutes. Okay, so this water is going for 6 hours and 4 minutes. And the household uses a 9 kilowatt hot water unit, right? So we have to times this by 9 kilowatts. And this will tell us how much energy the people are using based on how long they're using it for and how much power is coming out of their hot water system, right? So from this, we get 54 hours and 36 minutes, right? And that's in kilowatt hours. And it's charged at 11.97 cents per kilowatt hour. So all we do now is just times that number by 11.97 cents. So in our calculators, that works out to be 653.562 cents, right? Obviously we want it in dollars, so we just divide that by 100 and we get 6.5356. So that's just $6.54. And that is our final answer. So that is the electricity cost for the hot water used by this household in 1 week. Okay, so that's the end of the video. I really hope you guys enjoyed this lecture. I hope you guys learned a lot and are feeling more confident about the focus studies. If you're after a really thorough set of practice questions in preparation for your HSC, I really suggest you guys checking out the course notes we have in our shop on our website. It's just basically a really big set of practice questions that you guys can work through, and there's detailed solutions at the back, like written out solutions that you guys can check out. And yeah, I really wish you guys all the best in your HSC. If you guys have any questions for any topic in the course, please don't hesitate to ask me on the forums and I'll be happy to help you guys out. Thank you.